everything started here, and the recorder has started, and I think it would just be very funny if a faculty or professor of a different campus who's trying to teach mobile programming is just watching this to see how a class is taught. So so this message is for whoever professor is watching this. I'm just gonna say you're more than welcome to borrow my material. All right, so we are. I apologize that last week I had to cancel a class because I had to go to a event called Career GPS, where I had to talk to some middle school and high school students to basically tell them what computer science is and why they should consider coming to ARC as a community college. Apparently, a lot of students, especially high school and middle school students, do not understand that they can go to a 2-year community college and get a transfer degree and then transfer to a 4-year university. They just know that they have to go in as freshmen. They don't understand that there are other options, which is kind of interesting. Okay, so what I'll do is I'm going to do the homework assignment just a little bit and also show you what it looks like. Okay, so the homework assignment is called Drive, and this is really the first part of your homework assignment. It's not the whole homework assignment. So I'm just going to briefly describe what you have to do in this homework assignment first, and then we'll talk about how you can work with sprites, because that's where we stopped last time. I was not able to get to explain what sprites are and also how to use them. All right. So for this homework assignment, I'm saving you some trouble by giving you a starting point, and the starting point itself is kind of interesting and it already illustrates a lot of the things you can do with sprites. So we'll get to that pretty soon. Right click here and download a file that is called drive.zip. So I'm going to do that here. So right click on the link itself and then select save link as, because you will need to know where the file is so you can upload it back to App Inventor later on. And what I'll do is I'm going to rename it as drive2.zip because I already have a Drive project in my App Inventor. So I'll call this drive2 instead of just drive. Save the file. Okay, nothing special. You don't have to open the file here. Okay, so don't even try to open the zip file because it's not intended for your editor. It's really intended for App Inventor. So we're gonna open a new tab to go to App Inventor, and we'll go to the invent part here so we can get the tool started. I'm gonna use this account here. Okay, so I'll say allow and start the account. All right. Okay, there will be multiple projects already here. I'm going to re-upload Drive. See, I have Drive here already. So I'm not going to use that Drive. I'm going to use Drive 2. So what you need to do is to go to More Actions and then select Upload Source. Yep.
Does the file name determine the name that's listed as a project?
Yes. I think in the event that it is already there, it will probably ask you, or it will automatically rename it. It's not going to overwrite your existing project without asking you first. Okay. But in this case, it's called Drive 2, so I'm going to specify Drive 2 to upload, and then click OK to actually finish the upload process. And when it's all done, I should have a new project called Drive 2. It's alphabetically sorted, so it should be somewhere between Drive and Empty. Right? And it's waiting. There we go. So now we have 2 projects, and it automatically opens up the project here. And this is the screen. This is the resources editor screen. And you can see I have already done something to this project. It's not empty at all. It has got 3 canvases. Okay, not 1, but 3 canvases. The top part here is a canvas. This is the part where you'll be driving a remote control little car thingy. Okay, the bottom part has 2 canvases. This is one canvas. It has a steering wheel inside, and this is another canvas with a pedal inside. So these are the 2 ones that are already done. Okay, so I have already put in the logic for the steering wheel as well as the pedal. Okay, they can be dragged to control the direction and also the position of the pedal itself. So those are already programmed. All right. What is not programmed is what's happening up here. This black dot is actually a ball sprite, so it is a sprite by itself. It is already pre-programmed to go at in a certain direction, and when it bounces off the wall, there's a little bit of random factor. So that black little ball thing will just keep bouncing around. Ignore that for the time being, okay? So you don't have to mess around with the little ball here. What you need to do is to figure out what to do with this little sprite here that currently does not have any images associated with it. Now, I don't want to make you guys make any particular image, because you can make your own little car icon and make that the icon for this little sprite. Are we doing okay so far? Okay, so I'm going to show you how to upload a bitmap and then turn it into a sprite. Okay, turn it into the image of a sprite. Right now, this sprite has no images associated with it. There are several ways to do it. If you want to be inventive, you can actually just go ahead and use a draw program. You can use Windows Paint, which is always included in Windows, or you can use whatever tool you want to use to kind of draw a little picture. Basically it's a top view of a little car, or you can just go to Google and look for top view of a little car, and you can see if you go to images, there are tons of images you can just kind of borrow. So it's up to you, which one you want to use. Okay, so so let's just say that I want to borrow a NASCAR. This looks like a little NASCAR to me. Okay, so I can just go ahead and click on this one here, go to View Image, and here's the file. Okay, so I'm gonna go ahead and copy the URL to the file. So the way I do it, may not be the way that you do it. So it all depends on what tool you are familiar with. I'm really familiar with GIMP, and so I'm going to use GIMP for this purpose. So use GIMP, go to File, go to Open Location, type in or copy and paste the URL, click Open, and it doesn't like the URL itself. So, well, there are always other ways to do it. Just have to use a slightly different way. Right click, and then we can just say save image as. Okay, it's a Camry. Interesting. Okay, fine. So we just call it Camry as a JPEG file. And the JPEG file, you can just upload it already. This will upload without any problems. You might can also do some editing if you want to. So it's up to you how much processing you want to do. But since this is really just for demonstration purposes, this is all that I'm going to do. So switch back to App Inventor here, and then what you do is you have to scroll. Now, I have to scroll around a little bit, but most of you probably do not, because you're running at a higher resolution, not 1024 by 768. So you can see the whole thing already. You want to go to Media, which is under the Components pane, and then you click Upload New and go to Choose File, and this time I'm choosing Camry.jpg, the JPEG file, and just click Open, click OK here, and now it is uploaded. Once it is uploaded, you want to select, make sure the image sprite car is selected, and then go to the Properties pane. And you can see in the properties it has a lot of stuff that you can specify. Go to the one that says picture, click it, go down the drop down list and find your image for that particular sprite, click OK, and now we have a huge car here, okay, because it's just going for the native resolution of the sprite itself. So what you want to do is also to change the width and also the height of the image that you just uploaded. In this case, I'm going to make it a fairly small thing, because otherwise we won't have a lot of space on the screen to drive it around. So I'm going to limit this one to, let's say, maybe 64 pixels wide, and maybe 64, and I'm thinking about 48 is about right for the height here. It looks good enough, okay? So now we have a little car here. That's my sprite. It's actually pointing in the opposite direction because all sprites are currently, this sprite is currently heading 0 at 0 degrees, which is going to the right hand side. So this is actually backwards, okay? So you guys have to fix, stuff that you upload to make sure it's pointing in the right direction, because otherwise it will look like you're driving your car backwards, which will look kind of weird. Okay, but I'm not going to do any additional processing. I'll let you guys, figure out how to upload your image here. Okay, do we have any questions about this homework assignment up to this point? Up to this point, up to this point is all procedural. Okay, nothing really fancy or programmatic. Okay, so the next thing I want to do is to open up the blocks editor to show you what code already is coming with this particular program. So I'm going to open up my blocks editor, and I'll just go ahead and use an emulator today because I want to show you, what you can already do with the existing code of this particular project and how it's already done and how it is done, because all of that stuff has to do with what you can do with sprites and how to work with sprites. And I'm still always amazed by how fast this particular machine is. All right, so we'll go ahead and start a new emulator. And if you guys are trying to do it, on your side, you have to remember to re-download the App Inventor setup, because that part is not saved on these machines. Okay, so I'm gonna wait for the virtual machine to start up. That really is fast. I mean, that's much faster than my actual Android device. Okay, slide it open.
Maybe it has, the computers are hardware enabled for virtual machines.
Yeah, but these are not x86 type of machines, so the hardware acceleration typically does not work for cross architecture emulation. So
I think these are x86 variants.
Is it?
Yeah, because there's Android x86, and I think Google makes it just for the PC emulation.
So it's more efficient. That makes sense. That makes perfect sense. All right, so I'm connecting the machine. I have not even started on any type of coding because I want to show you what is already done at this point. Here we go. All right. And here we have the little app running. You can see the black dot is running around all by itself. That's because it is already specified to do all that stuff. So what I'll do is I'll explain how the steering wheel works and how the pedal works. If you put your hand, and drag the steering wheel itself or the pedal, you will see that, okay, I'm just going to do here. I'm pressing the mouse down and keeping it down to simulate a drag. You can see that I can actually turn the steering wheel just by dragging it at a certain point, and I can do the same thing with the pedal. So I can drag it, and basically floor the pedal. Okay, this should go fast when it's floored, and now it should not, it should coast to a stop or just stop. Okay, so are there any questions about the functionality of the steering wheel and also the pedal? That part is already done. That code is already done for you. No questions about it? Okay, so the next thing I want to do is to show you what the code looks like corresponding to the steering wheel and also the pedal. Okay, the pedal is not too bad. The steering wheel took me a little bit of time to figure out how to do it. Okay, because I basically had to discover what functions are already available in order to make it turn at a certain angle. Okay, so I'm gonna hide this one first and show you the code here. The code up to this point is really, really simple. Okay, in fact, I have some code that is dysfunctional. It's not even used at this point. The first part is, okay, let's take a look at this block first. Okay, this block corresponds to image sprite touchdown. Okay, so what it does, or when it gets triggered, is as soon as I touch on the steering wheel sprite itself, this particular event will happen. Okay. And when that happens, there's only one thing for me to do. I am setting a global variable called initial angle to a particular angle. Okay. The reason why I'm doing that is because if you look at a steering wheel, it is a round thing, right? So this part I'm drawing on a whiteboard here. Okay. so the steering wheel is a round thing. I don't want you guys to also have to grab onto this point here in order to drag it and make it turn. In other words, I want it so that you guys can click any point within the steering wheel, let's say here, okay? And it will just remember that you initially contacted this point. So from that point on, when you move your hand or your finger around it, it will just grab that particular point of the steering wheel and turn it. So that's why it is important for me to remember the initial angle, which is this angle here. This is 0 degrees, and this is the initial angle also in degrees. Are we doing okay so far? So in order to figure out this theta, which is the angle from 0 degrees, fortunately there is a function built into App Inventor to do all this stuff. It's called arctangent, but not just your regular arctangent, which works on the ratio. This is arctangent 2, which only requires x and y, or the relative position of the point from the origin of rotation, and you just have to specify x and y. Now, if you think about x and y, we already have x and y from the touchdown event itself, which reports the x and the y coordinate within the canvas where the sprite is located. So that should be enough. Well, as it turns out, it's not, okay? Because I'm not really interested in the position of the touch event itself. I'm only interested in how it relates to the center of the steering wheel, okay? The center of the steering wheel is always at the center of the entire canvas in this case. So you can see how the equation works here. This is basically, a subtraction event, a subtraction calculation. I'm subtracting the y coordinate from the height of the steering wheel canvas divided by 2. Okay, so let me just use the whiteboard again to illustrate what I mean by that. Okay, so you can imagine that there's a canvas surrounding the entire steering wheel. Okay, and so this part here is the width of the canvas, and this is the overall height of the canvas. The steering wheel center is at the exact center of the canvas itself. Are we doing okay so far? Okay. So when you touch a particular point, let's say this point here, I want to know, how this point relates to the center of the steering wheel, which is also the center of the canvas. Are we doing okay so far? All right. So to get to this point, relative to the center, all I have to do is to take the coordinate of this one here. The x-coordinate is easy. Okay, the x-coordinate is just whatever it is here, and I have to subtract half of the width of the canvas from the x value, which is what you see on screen here. Is the bottom part here. I'm subtracting the value. I'm subtracting half the width of the canvas of the steering wheel from the x value of the touch point. Okay, the y one looks reversed. Looks like I have a problem with the y one. Well, it's not reversed because the way the y coordinate works when we are looking at the touch point here, this is 0, 0. This is location 0, 0 in the canvas. Okay, so the lower you go, the higher the y value is. But when you are using arctangent, it is the opposite. Okay, when you're using arctangent, you want this point to have a positive value. So that's why I have to reverse the sign or reverse the subtraction, so that this point here would actually have a positive value, and then this point here would have a negative value. Are we doing okay so far with the math of the steering wheel? Okay. Now this part you don't have to do a single thing about it. Okay, it's already done. I just want to show you how the code is done. Okay. And then, are there any questions about how to use a global variable? To make a global variable, you go to My Definition under Built-in, okay, and you can see there's one little blue tab here that says Define Variable As. So what you do is you just drag the block out, change the variable to whatever variable name you want to use it to name it. So I'll just call this new global variable, and then you also have to give it an initial value. So this part here, this socket has to connect to a particular value. I just attach most of mine to a number, and initialize that to 0. This is how you make a new global variable. Now, once you have a new global variable, you can use the variable throughout the entire screen here. Okay, which means a global variable is not truly global. It is only global within a screen. If your application has multiple screens, then a global variable from one screen cannot be seen by another screen. And that's why you have to rely on TinyDB to move information across the screens. Are we doing okay? Doing okay so far? Okay. So in this case, I don't really need this made up a new variable here. I'm just going to toss the whole thing into the trash can because I don't really need it. Okay. There we go. All right. So once I store the initial angle, the rest of it is just dealing with the drag event. So I'm going to show you how I process the drag event itself. Okay, so let's see, it's right over here. Okay, this is a drag event, but for the entire canvas and not just for the steering wheel sprite itself. Originally, I had this, in the associated with the sprite itself, but there was a delay effect, and I was trying to see whether if I move it over, would it change anything? No, nothing changed, but it still works the way it is. Now this is actually sensing a drag event inside the canvas, but it does report. Okay, if you look at this particular parameter here or argument here, it's called dragged sprite. It is a true/false value. It is true if the drag is starting on a particular sprite, and it is false if it is not on a particular sprite. Okay, so I'm using that to determine whether I really should do anything or not. At this point, I'm assuming that everyone has either taken a class in some kind of programming or is taking a class right now. Either has taken a class or is taking a class that will talk about programming. So I'm assuming that everyone should be familiar with a conditional statement at this point. Okay? If you're not familiar with what is a conditional statement, then you really should take a programming class, because this class has a prerequisite of cisp300 or cisp370. So I cannot really go into detail to talk about what a conditional statement is. Okay, and you can see the rest of this is really about the same, except I'm not changing a variable called initial angle anymore. Instead, I am just changing the heading of the sprite. Now in this case, the sprite is the steering wheel itself, so I'm changing the rotation so that it displays correctly. The math involved is about the same. Okay, you can see A tangent, arc tangent 2 is the same thing as last time. Okay, I'm still using the same equation just like last time, except this time I have to refer to the argument of this particular event handler. I have to refer to current y2, which is over here, and current x2, which is over here, instead of the other one, which is just x and y. There's only one little difference here. I also have to subtract initial angle from this particular angle, because otherwise it won't track the point that you initially touch. So I'm using the point where you initially touch, or the angle to the point where you initially touch, and say, okay, because at a later point, if your drag point is, let's say, over here, but you have never released the touch, I only want to turn the steering wheel by this much. Okay, so that's why I have to look at this angle and then just subtract the initial angle, so I know I only have to rotate it this much. Do we have any questions about the math of the steering wheel? That actually is by far the most complicated part of this entire program, is to keep track of the rotation itself, because I have to do the arc tangent in order to go back to the angle, and then I have to track the initial angle and make sure that it looks right. Any questions about that part? Nope. Okay. But you learn at least one thing that is important, not in your current homework assignment, but in your future. The next one is going to be helpful. That has to do with the heading of a sprite can be changed. Okay, not only can you set how fast it's going you can also change its direction. But you will see another example regarding the change of heading. Okay, so that's the steering wheel. Let me just go back to the app here. So this is the steering wheel, and you can see how it works. I can grab onto maybe this point here. I can start dragging from here, but you can see that, so you can see that that point, it continues to be the point where you're dragging it, like you're holding on to that part of a steering wheel. And in theory, you can turn it in 360 degrees. The math works out to be like this. Okay, when it's fully upright, like not fully right now. Drag, come on. Okay, so when it's like this, it is actually at 0 degrees. When it's upside down, it is either 180 or negative 180. Okay, so because the full circle is 360 degrees, so that means 180 and negative 180 are basically the same thing, because they're really the same type of rotation, one full rotation. But they're basically upside down. Are we doing okay so far? And you can also see how the black dot, that keeps moving around, it can go to the point where the car is, and once it gets past the little car, it will erase itself. I mean, if everything works out just fine, you don't have to repaint any part of the canvas. That is a property of a sprite. It can actually do all that stuff automatically, so you don't have to worry about restoring a certain part of the screen. You just have to think about, okay, how fast is that thing going, and where is it going? What is its heading? Okay, any questions? Okay, next thing we want to take a look at is the paddle itself. Okay, so I can do the same thing here. I can grab on any point on the paddle, let's say this little corner here, and then I can do the drag action. And you can see how the drag action maintains basically the same relative position to the paddle itself. Okay, so the way it works is actually about the same, except it's a lot easier in this case. I'll show you the code corresponding to the paddle itself. The paddle is really simple. Okay, it's really just this little script here that handles the paddle. And once again, I'm using the dragged event of the canvas and not on the sprite itself. But if you look at the code, it is really simple. It's basically checking whether a sprite, whether the paddle itself is actually getting dragged. Now, since that canvas only has one single sprite, so that means if a sprite is in fact touched, it has to be the paddle sprite. There are no other sprites in that canvas. And this one is really quite easy, because all I did inside here is to change the y coordinate of the sprite paddle by this much, by the difference between the current location of the drag and also the previous location of the drag. So with each event happening, I'm only going to make the change, the relative change of the y coordinate to the sprite. And that's all I'm doing. Okay, so it is considerably easier compared to the steering wheel, where I have to handle the initial touch first, figure out the initial angle, and then make all the changes relative to the initial angle. This one is really just saying, oh, we'll change the relative position of the paddle by the delta, or the difference between the drag events, by the event handler. Are we doing okay so far? So two things you really need to think about is, how do I know the current state of the steering wheel, and how do I know the current state of the pedal? Because those are the two things that you need in order to control your little car, your RC car, around the course. Okay. What about that little black dot thing? Okay, so if you go, let's go back to the simulator here. The little black dot seems to be there seems to be some kind of logic going on there. I mean, it's able to move around on its own and bounces, and it keeps going at a certain rate. Well, it's all kind of automatic except for one little thing. Okay, so I'll show you the code for the little black little dot here. Let's go back to the editor here. The little black dot is called a ball sprite, And a ball sprite, now that I have selected it, we can take a look at its properties. One, it is enabled, which means it is moving on its own. Okay, enable does not control visibility, and they are basically two separate things. You can disable a sprite and still have it visible, which means it's just a dot sitting there doing nothing. Or I haven't really tried the reverse, having it enabled but having it invisible. Okay, so it's happening in the background. The first thing you notice is, it has an initial heading. Okay, this is the initial heading, which means when the app is first loaded, it has a heading of 45 degrees. 45 degrees is going this way. Okay, because 0 degrees is going to the right, 90 degrees is going to the north or up, so 45 degrees is going, at an angle at the upper right-hand corner. Okay. Now the interval is in number of milliseconds. This is what this is saying is every 100 milliseconds, which is a tenth of a second, is going to move. Okay, so it's going to move on the average. Under ideal conditions, it will move 10 times per second, or 10 hertz. Each time it moves, it's going to move 5 pixels. Okay, that's what the speed is. The speed is basically saying in number of pixels, how many pixels should it move at every interval. So in this case, it is moving 5 pixels every 100 milliseconds. So in 1 second, it's going to move 50 pixels because there are 10 100 millisecond intervals within a second. It has the initial XY coordinate. Okay, these are only controlling where it started. The Z controls whether it is visible when sprites are on top of each other. The Z setting can determine which one is visible, which one is on top. The higher the value, the closer it is to you, and therefore it will overlap or cover the other ones below it. We're still doing okay so far with this. Okay, very good. But this alone is not going to explain the behavior that we are observing in the simulator, because in the emulator, not simulator. So in the emulator, we can see that the ball doesn't, right now it's not going at 45 degrees. I mean, this is a little bit less than 45 degrees. And it bounces too. At the end of at the boundary or the edge of the canvas, it would actually do the bounce, and bounce off at a slightly different angle. It's all kind of randomized a little bit. So that means it's not really just the properties determining how the little round ball is moving. There's actually some code associated with it. So now we'll go to the code itself and figure out what code is associated with it and how is it all written. It's actually very, very simple. Okay, this is the entire script related to the little black ball. All it does is to do this part here. It's an edge-rich event handler. In other words, whenever a sprite that can move by itself is reaching the edge, when it touches the edge of a canvas, this event will happen. Okay, it will just get triggered. This code will get triggered. It has an argument called edge because it can be used in a bounce action. So what's happening here is the first thing it does is to do a bounce. A bounce means if it is hitting something at an angle, it will bounce off at a reflection angle. Okay, does everybody understand what I mean by reflection angle? Okay, so if you bounce into a wall like this, it will basically bounce back at an angle, and the angle of incident is maintained. Okay, so it's just like a mirror. Okay, so think of the edge of a canvas as a mirror, and it will be a perfect reflection in this case. But a perfect reflection would not be a whole lot of fun when we're playing a game, right? So what I did here is I'm also changing the heading with a little bit of an random factor here. So I'm setting the heading of the ball to the heading of the ball plus a random number. The random number is from the math tab, in the blocks bin, and you can specify from what number. In this case, it's -15 to +15. So that means every time it bounces, it will pick a random number from -15 to +15 so that I can change the angle of the reflection just a little bit. So this way, there's a little bit of random factor in the game. Are we doing okay so far? Still okay? All right. So let's go back to the homework assignment and see what you have to do with your homework assignment. I think by this time all of you should be ready for the homework assignment. Use any program to draw a car or download an image of one. You should have an image file at the end of this step here. So I just did that by using Google Images. Upload the car image file to the project as a resource. Okay, that's the second step that I did, and I ended up with over here. I ended up with a Camry image in that app. Okay. The third step is in Canvas course, which is the canvas containing the car. There's a sprite called image sprite car. Do the following to that sprite. Specify the image, specify the width, and specify the height. I pick different numbers. This will make the car a lot smaller, which gives you more room to maneuver the car when you're driving it. And for now, ignore the bouncing ball. Make the car go at a speed that is proportional to the position of the image sprite pedal. Okay, so that's one of the challenges. Okay, you have to figure out how to make the car go at a speed that is proportional to the paddle itself. Okay, let's take a look at the paddle. Okay. This is the paddle, and in the app itself, this is the paddle. The initial position is all the way up here, and at that position, that means you have not pressed on the gas pedal, so the car should not move at all. Okay, it should be stationary like the way it is right now. On the other hand, if I press the pedal, which means you drag the pedal down to about here, it should go at half the possible speed. And if you drag it all the way down here, it should go at a maximum speed. Are we doing okay so far? The Y position of the pedal is going to determine the speed of the car, okay, which is a sprite. Getting back to the homework assignment, I'm going to tell you how to scale the pedal, which means when it is floored, the speed of the car should be 5 pixels per update. You don't have to mess around with the interval, so it will still be using 100 millisecond as the interval. You're just changing the speed. Okay, when it's all the way down, when you floor the gas, it's going to move at 5 pixels per interval, and there'll be 10 intervals per second. So that way your car will be moving at the same speed as the bouncing ball itself. Any questions about this part? No questions? Okay. And the last part is, when the car hits an edge of the canvas, just use the bounce method, so it will bounce back. So it just go back and forth, because you're not going to bounce at an angle, so it will be kind of boring, because your car would hit one of the edges, one side, it would just turn around, and then we'll go in the opposite direction, hit the other edge, and then turn around again. And that's the expected behavior of the code that you're going to turn in for this homework assignment. So you're absolutely right. There's nothing that you have to do with the steering wheel, okay? And that's because, with the steering wheel, we have to add another component into this whole thing, because a sprite doesn't have a turn factor, okay? You specify the heading, which way it's supposed to go, you specify the interval, you specify the speed, and it will go at a certain speed. But it doesn't turn, okay? It doesn't go like this, okay? It just goes straight at a certain heading. So how do you factor in the turning part with a sprite? Well, there's no easy way to do it, okay? You have to use a clock to do it, because you have to set up a clock, so the clock will generate events every 100 milliseconds or so, and then every 100 milliseconds, you change the heading of the sprite in order to make it make a turn, okay? But at this point, I'm not going to do anything about it, because we are just going to limit ourselves to what we are doing in this homework assignment. In the next homework assignment, we'll also introduce steering, and then we'll also introduce okay, what is that bouncing ball doing in this game? Well, guess what? When this game is all done, you have to avoid the edge, so you don't want to run your car into a wall. and you also want to avoid the bouncing ball. In other words, you don't want to collide with the bouncing ball. If you do, then we'll deduct points, or it will cost you 1 round, and you only have like 3 rounds, so that So that's basically what the way we are going to do this game here. Are there any questions about this homework? Yep.
You said 5 pixels per update and 5 pixels per interval. What do you mean by that?
Well, when you look at the simulator or the emulator, I keep saying simulator because the emulator, do you see how the ball is updating itself? Tick, 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 like that? Every time it changes position, that's an update. And that's 100 milliseconds, ideally speaking.
And that's also an interval.
Yeah. Yep. It's a time interval. All right. Are there any questions? Yep.
So we're just making the car go left and right and bounce
Yep.
off the walls, not
Yep.
randomly changing angle or anything. It's just
You don't have to randomly change angle. It's just bouncing left and right.
Okay.
Yep. So it's a lot easier than what I have done so far. But one thing you do have to add is to control the speed depending on the pedal itself. Okay? So there are 2 questions now. One is, where do you add the code to change the speed of the sprite? Okay? What is going to trigger that change? So you have to associate your code with the event that is changing the speed. Okay? I'm not going to tell you where you have to attach the code. I'm going to let you guys figure out where to attach the code. And then once you attach the code, how do you do the scaling? Okay, because the pixels are at a certain scale, so you have to scale the whole thing. So when you floor the gas, it is 5 pixels per update. Okay, that's a division, but you do have to kind of look into it and figure out, okay, what is the 0 position here, and what is the position all the way down there, and then you have to do the math accordingly. Are there any questions about this particular project? I don't want any fancy stuff like, but I'm going to control acceleration so the speed of the car would actually gradually increase. No, you don't have to do anything like that. It just has to be proportional to the pedal itself. Okay, because I know.
Is there a start button someplace? Is there a start button someplace?
No, there's no start button. You just start pressing on the gas and the car moves. There's no start button like a Prius. Yep.
Control the steering wheel and the gas pedal at the same time? Use 2 fingers with 1 finger?
No, you cannot do both at the same time. So that makes running this game a little bit fun, because you can either steer, or you can either change the steering, or you can change the speed, but not both at the same time, like with a real car. Now, yeah. Now, when you guys are really experienced with this stuff, you can actually tie the steering and also the speed to a tilt of your mobile device. You see what I mean? You can actually drive the car by controlling the orientation of the device itself. So that way you have one to control the steering, and then you can use your touch to control the speed. But we are not going to do that first, because we are dealing with sprites now. So I'm just going to use sprites for that purpose for the time being.
And when the pedal is 0 position, there's no motion of the car.
When the pedal is all the way up, there's no motion, because the updates will be at 0 pixels per every 100 milliseconds. You don't have to change the period, just let it stay at 100 milliseconds. Okay, are there any questions? No questions? All right. If there are no questions, what I'll do is I'm going to use another sample program to illustrate a lot of the things that we talked about last time. Well, maybe, did we even talk about sprites last time? We did? Okay. All right, so what I'll do is I'm going to switch back to the notes. Okay. And I'll write some additional sample programs to illustrate what you can do with sprites. So, way down here. There's a lot of stuff you can do with sprites. Okay. For instance, what you can do is you can change the image as the sprite is going. Okay. Now, what is okay? Let me just do two things first. Okay, and then we can take a look at what are the fun stuff you can do with sprites, because it's really one of the most important things if you want to write a very simple two-dimensional game. Sprites are extremely useful for that purpose. All right, so we'll go back to App Inventor, and this time let me close the other screen first, just to be sure that it has saved everything. Okay, so I'll go ahead and close it. I don't really have to. I think if I switch projects, that part is automatically updated. And then I switch back to my project screen, and I'll start with a new project. So I'll go ahead and start a new project, and I'll just call this one Collide, because I want to see what happens when two sprites collide. Okay. So with this one, I'm going to start with something real simple to begin with. Give it a canvas, and the canvas is going to have a fixed size. Let's say it's 300 pixels by 300 pixels. So, all right. So now we have a canvas. Now, when you specify sprites, they'll be under animation, and the ball sprites are easier to use because you don't have to upload images in order to be used with balls. So I'm just going to use two ball images here, and you can see that I can drag and drop sprites directly onto a canvas. There are no other places you can drag a sprite into. You can drag a sprite into the rest, and it doesn't do anything. So all sprites must be dragged into canvases. Now I have two sprites. One is ball 1 and one is ball 2. So I'm going to change the color so I can easily tell which one is which one. So with the first one, I'm going to change the color to blue. And with the second one, I'm going to change the initial color to green. So now I have two sprites, one blue, one green. And we'll go ahead and do some programming here. We can change the size up to 2. So we'll go ahead and change the first one to a little bit bigger. Let's make it like 15, as a radius, and then we'll change the second one maybe to 15 also. So this is just controlling the initial radius. You can change the radius with your own code if you want to. So we'll go ahead and do something about that. Okay. Are there any questions? This part is pretty, fairly simple. We'll go ahead and also change the direction here, the heading. So with the first one, the blue one, will have an initial heading of 30 and a speed of, we'll make it 5. And then with the green one, we'll have an initial heading of, let's say, 60 degrees and also a speed of 5 as well. Okay. So now without, using any type of code on my own, I'm going to open up the blocks editor. Okay, just click there. Start up the emulator again. I think the emulator is still running. I just have to make a connection to it. So I just have to connect to the emulator that's already running, and there's no code whatsoever. So the question is, with no code whatsoever, will this app still do something? Okay. Well, since sprites are called animation, I think some of you probably would expect, yeah, we will expect something to be happening, even though there's no code written whatsoever. It's not going to be a whole lot of fun because there's no bounds either. So we'll see what happens when we don't specify bounds. So without specifying bounds, it's just sticking, and once you get to the end of both edges, it just stops. Okay, it just cannot do any further updates at that point. Okay, so at this point the app is like not a whole lot of fun. All right, I really hate to do your homework, but I need to do this part, just so that it can be, I can show you what I need to do. Okay, so I will go to ball 1 here, and I'll say, I'm doing your homework.
We won't look.
All right, so that's one, and here's the other one. All right, so now I have just updated the code a little bit. Go back to the emulator, and you can see it's a little bit more fun. I mean, you can definitely see the two balls are now bouncing around and not getting stuck at the corner. Okay, alrighty. Okay, so they can overlap. The green one apparently has is overlapping the blue one, even though they have the same value. Okay, not a whole lot of fun here. So what we'll do next is to say, well, maybe we should do something when the two balls, hit or collide, or when they touch each other. Okay, so we'll see, what's going to happen when they touch each other, and what else can we do, about sprites colliding. Okay, so these two we're gonna take it, put it to the side here because we are not gonna focus on these. So we'll go to ball one here, and then we'll take a look at the event handlers. Okay, and we have the usual ones. We have drag, we have edge reached, which we used a little bit here. We have flung. You're basically starting a swipe action on a sprite itself. And then we have two really weird ones. One is called collided with, and then one is called no longer collided with. Okay, we'll just use the first one first and see what it does. Okay, so we drag it here, and it has one argument. The argument is called other. Okay, that's a default argument name for other. It's basically what is it colliding with. Okay, it is another sprite.
The name of the sprite?
It is another sprite, so basically you can use that as a parameter later on.
The name?
It's not the name, it's actually the object itself. Yep. Okay. So if you put your mouse pointer over it, it explains what it is. It's a handler for collided with event called when two sprites collide. So it can only collide with another sprite, it cannot collide with an edge. Okay, so an edge is not considered a sprite. Note that checking for collisions with a rotated sprite image sprite currently checks against the sprite's unrotated position. Therefore, collision checking will be inaccurate for tall, narrow, or short, wide sprites that are rotated. Okay, that's fine, no problem. Okay. All right, so that means we're colliding with something else. Let's say that I'm not even interested in what it is colliding with. I'm only interested in, okay, I want to be able to tell that it is colliding with something, and I'm going to change its color to a collision color. So this is ball one here. I will go to ball one and say change the color of ball one. And it's right here. Change the paint color to something else. I will go to built-in, go to colors, and then pick, let's say red here. Okay, red usually means something dangerous has happened. So this is what I'm going to do. So go back to my simulator here, and the code should be uploaded already. So we'll just wait for the collision to happen, which is pretty soon. Yay! See, the color of the first one, which was blue, is now turned into red. But it stays red the whole time, okay? Maybe I want to turn it red only when it is colliding with the other ball, and then after that, maybe I want to switch it back to the original color. Is that okay so far? Okay. All right. So let's see how we can do that. Okay, and I'll use two different approaches to do exactly the same thing. There's actually a third one which is even better, but I'll just talk about the two that I will talk about here. Okay. To turn the color back to blue, I have to figure out when I'm going to turn it back to blue. There is one particular event handler that is useful, which is this one here. Because I want to turn it back into blue when the two balls are no longer colliding or no longer overlapping. So I want to turn it into blue back here. So that's pretty easy. Okay, you can actually just click this block here, do a Control-C to copy, do a Control-V to paste, and then I can just change the color to blue. Like that, and my program is done. Okay, now it doesn't change it to blue automatically like this because it's waiting for no longer colliding with. So that means it has to collide first, and then it will switch back to blue when it's no longer colliding. So that works, that code works, okay, not a problem. But it has one little issue. If I want the green ball to behave the same way, then the green ball will have to have no longer colliding with to set the color back to green. So one way to do this is to save the original color of the ball before you change it to red, and then later on restore it back to the original color. Okay, so that's one thing you can do, is to save the color first and then change it back to that original color. Okay, are there any questions about this app at this point? No questions? Okay. Maybe I want to make an explosion event. Yep, go ahead.
On the ball collide with,
Mm-hmm.
just do a time statement, between the 2 and the color, where it says, I only want the color changed for, 100 milliseconds.
No, you cannot. You will have to use your own timer. Basically you have to use the clock to do that.
Yeah.
So there's no easy way to to time it and say I only want to do it for 100 milliseconds.
Okay.
Yep. Okay, so maybe during this collision I want to change the size too, because it's an explosion, right? Okay, so let's go ahead and see how we can also change the size of a ball. I mean, a ball is really easy to work with because the size of it is actually just controlled by the radius, right? So what I can do here is I can change the radius itself, set ball radius, and I just need to specify something that's bigger. So right now I think it's at 15, so I can now change it to, let's say 30. Okay, double the size when it's under explosion, and we have to shrink it back to whatever it was after the collision. Okay, so let's switch back to our emulator here. Okay.
Already happened.
It happened while I was changing the code. So one's bigger is a little bit lopsided. Oh, close. Ding. There we go. All right. So are there any questions about this? There are other things you can do with sprites too. Let's go ahead and take a look at other things that you can do with sprites. So we'll go to my blogs, go to a particular sprite here. There are several things that are particularly useful. Bounce we talked about already. I think I cannot talk about bounce anymore. This is a value. It is a true/false value. So it's either colliding with or it's not colliding with something. Okay. And the other has to be a sprite itself. Move into bounds, same thing. It's either true or false. It basically says whether move the sprite back in bounds if possible. Okay, so if it's out of bound, it will move it back into bound. Move to XY. Okay, so this will teleport the sprite. Okay, which will make a very abrupt change of position of the sprite. So we'll go from whatever it was before, and it will just move to a certain location. And then we have point in direction, which is actually very useful. We also have point towards, and then it has a target. Now that is a fun one, okay? Because what point towards is going to do is to say, change the orientation to a particular thing, okay? And what you're changing the orientation toward has to be another sprite. So if I overwrite, if I just hover over here, so it'll point the sprite to pointing toward a target sprite. Okay, so we'll take a look at what we can actually do with this one here. Okay, so maybe after a collision, we'll go ahead and specify that here. Well, maybe not. We'll go ahead and change the program a little bit, and we have a button to trigger that. Okay, so that's even better. So I'll go back to the original design view here. Instead of a button, I'm going to do something a little bit better. I'll go to basics, and then we'll use a checkbox to do that. Okay, because a checkbox is really good because if I want to turn on and turn off something, a checkbox can handle that by itself. So all I really have to do is to check whether it is on or off, And guess what? The other thing that's good about checkboxes is whenever I change the state of a checkbox, it triggers an event. So that way I can actually turn on something and turn off something as the checkbox is changed. So we'll go ahead and use a checkbox for this purpose. And we'll change the text of the checkbox and say enable chase. Okay, there we go. So that's what we will do. What we'll do next is to change the code itself to make use of the checkbox. So there we go. And now we have a checkbox here. Well, first we'll take a look at the events of a checkbox. There are only 3. One is changed. Now, when it's changed, it doesn't mean whether it is checked or unchecked. Okay, it's just okay. It's changed. Okay, maybe it was checked before, now it is unchecked. Maybe it was unchecked and now it is checked. It doesn't matter. It will trigger the same event, and that's the event that we're going to use in order to change the behavior of the sprites that we have. Okay, when checkbox 1 is changed, we're going to do something. So what we'll do is we'll change the behavior of ball 1 and say, okay, we'll make ball 1 point toward ball 2 using this call here. Okay. Oh, yeah, actually, I have to take this back because I have to check whether it's checked first or unchecked, right? So I need a conditional statement in that case, because whenever I have to choose one way to do something amongst 2 paths, I need a conditional statement. The conditional statement means, I can make a decision, go in 2 different directions, but I can only pick one way to go. So we go to control, we have if then else. Okay, so we pick that, stash it here. And then the test will be the state of the checkbox itself. So we go back to my blocks, go to checkbox 1, and then go to its properties and say checkbox1.checked. Okay, because this block checkbox1.checked is going to be true when the checkbox has a check mark on it, and it will be false when the checkbox disappears. So this way I can choose, I can determine which way how I'm going to do this. So I will, in one case I will say, yes, make ball 1 point to a target. Now the question is, how do I specify ball 2? Because if you look at ball 2 here, if you scroll all the way down to the bottom, this is how you specify to have ball 1 to point to ball 2, because ball 2 is now identified as a component. Okay. And if the checkbox is unchecked, I don't want to chase after ball 2 anymore. So what you can do is to make it go in a random direction, or just do. I'm trying to think of what to do here.
Ball 1.
Well, it's ball 1 cannot chase itself. It's.
No, I just didn't know if there was any settings under my blocks ball 1 that would specify random.
You can set the ball 1's heading to its current heading.
Yeah.
Okay, let's just do this one here and see whether the chasing is continuous. In other words, I haven't even tried this yet. Okay, that means when I specify ball 1 to point towards ball 2, is it only a one-shot deal and it will just align the direction right at that time, or is it going to keep chasing the other one every time it updates? Okay, my guess is it will only turn one time, and then it will just forget it. Okay, so we'll take a look and see whether that's the behavior or not. So there's nothing else to specify here. We can just leave the else empty, and we go back to the emulator here, and we'll make them chase. Yeah, so it doesn't actually do anything. It's the chase is only one time. It only adjusts the direction once. Okay, so it's not quite doing what I wanted to do, because I wanted to chase after the other one. Alright, so if that is not working, what am I going to do? Oh, just give up. It's too hard. Can't do it, right? Well, what I wanted to do is to have one ball to, once the check mark is on, I wanted to constantly realign its direction to the other sprite, so it will be chasing the other sprite, right? Okay, I cannot do it, automatically. Okay, there's no automatic setting to do that part. But what I can do is to say, you know what? Every 100 millisecond, I want you to readjust your heading to point to the other guy. That I can do. Okay, so let's see how we can do that part. I think we have already talked about how to use a clock before. Yes, no, maybe. Okay, so we'll go ahead and use a clock here. A clock is a non-visible component because it really is just something that is not displayed on the screen, but it does have some properties. It has 3 properties. I'll explain the 3 properties here. The first one is always fires. Okay, always fires means it is re-enabling itself. It's not a one-shot deal. In this case, every 1,000 milliseconds, it will do a click. And then it will wait another 1,000 milliseconds, which is 1 second, and it will do another click. If you turn off always fires, then it will do one event and then it will stop. In other words, it's non-repeating. The first one really should be saying repeating or not. Okay. The second setting, which is enabled, is whether it's enabled, because if it is not enabled, it's not going to do anything. Okay, it just absolutely will not trigger an event. And then the interval here is how often is something happening. Right now it's set to 1,000 milliseconds, which means every second. I want it to happen at about the same update interval as the sprites themselves, so I will specify that to be 100 instead. Yep.
You have more than one instance of clock?
Yes.
Clock 2, clock
You can have many different clocks. The drawback is they are all really sharing the same processor, so they cannot all go off at the same time. So if you have 2 clocks going off at the same time, then the first clock will do whatever it needs to do, and then the second clock will do whatever it needs to do. So everything will still be kind of sequential. Yeah, there will be a delay.
So like, for example, if you have one at 100 and then the other one at 1,000,
Right.
they both meet back up again, whichever one you have before the other will process before.
Yeah.
Does that make sense?
Yeah, it doesn't. Yeah, it's just not at the same time.
Okay.
Yep. All right, so we'll take a look at the blocks editor here and see what we can do with the clock. Whoop, that one. There we go. So when you look at clock 1, you can see it has a lot of stuff. I mean, only one trigger. Okay, when clock 1.timer, the timer has gone off. In this case, every 100 milliseconds, this event will happen. So it looks like that can be helpful to us. And it has a lot of other things too. A clock is really a clock, so you can actually use it to calculate time, date, and so on and so forth. But that's not why we are using it, so we'll ignore all the other stuff. What we'll do instead is we're going to move this block over here. Because all we're going to do is to say, if the checkbox is checked, then realign the direction of ball 1 to ball 2 at that moment. So every 100 milliseconds, it will do that if the checkbox is checked. Okay, and the program is already running, so we'll go ahead and take a look at the program. Right now, it is not enabled. Okay, now it has enabled, and you can see how the blue ball is now chasing the green ball. Bing! Oh, it can never get out now. Those two cannot get, because they're going at exactly the same speed. So the green ball can no longer escape from the red ball, ever.
What if we change the speed of the green ball to like
Yeah, you have to make it so that when it's
50 50
exactly. You know what? You can also calculate the distance between 2 sprites, and then use that to increase the speed of the one getting chased. It's like it will speed up a little bit.
Oh, that's funny.
All right. So I can disable it now, but it's I guess because of the slight difference of the angle, they can still kind of stay out of each other's way a little bit. And I can enable it. Oh, okay. They have to be slightly off to begin with. See, they're already slightly off, and then can re-enable it. You can see how the blue ball just turned around and chased after the green ball, as soon as I enabled it. So, are there any questions? Does anyone want to write a game now? I mean, I think this is pretty easy to program. To write a game, you can have one sprite, as an alien ship, one sprite as your turret, and one sprite as the projectile that you're shooting. Okay. And you can shoot different types of projectile. You can shoot like just a plain projectile, or you can shoot homing missiles. Right? Tracking. Any other questions? No one seemed to be excited. It's like, turn your driving game into a driving and shooting game. And you're driving, and then if you want to shoot, I guess you can use the voice and just scream, shoot, fire. Are there any questions? Yep.
I have one about the homework.
Okay.
The pedal, like the Y value, can be greater than the size of its limit.
You have to cap it then.
Yeah.
Yep.
Well, in your program, like the Y value can go greater than the limit of the box. Like the pedal itself can't move outside of that. But the Y, like the program registers the Y value as greater than.
Okay.
It's 150 pixels for the box. It registers up to 180.
Then you have to cap it.
Okay.
Yep. To cap it means, if the Y, okay, let me just switch back to the homework. Okay, so in the homework, what Chris was saying is the Y coordinate of the pixel can exceed the canvas height itself. So when it is exceeding the maximum value, you have to cap it and basically say, okay, any value further than that, greater than that, will be capped to a particular value. So are there any questions about the homework assignment or anything related to sprites? Now, right now this game is really boring because it doesn't have any sound effects. So you can basically see, if you want it to be more fun, you can actually attach sound files to, like a small explosion sound, when they're colliding, or just a beep, if you want to. So you can actually add quite a few things, to whatever we already have to make it kind of an interesting game. The other thing you can also do, okay, for those of you who are adventurous and really want to do something with an Android device, is to have one ball to be automatic, so it's just bouncing around, randomly, but have the other ball to be controlled by the tilt of the device. Okay, so this way, when you tilt, you're actually changing, the other ball, how it moves, and then you can try to use that so that you can control one ball to avoid, hitting the other ball, or have it to, basically try to run into the other ball. So that will make it more, interesting, because now it's much more interactive. But it's also not easy to do because there's no direct linkage between the accelerometer and also the movement of the sprite. So that means you have to use the clock here to basically remeasure the accelerometer readings every 100 milliseconds or so, and then change the heading and also the velocity of the ball accordingly. Okay, so that's not as easy as what we have just done here, but it does make the game more fun, because now it's much more interactive. Any questions? Now, personally, I think the concept of sprites definitely make it easy to write entertaining games. We're not talking about Angry Bird kind of entertaining, but still, I mean, being able to throw something like this together, in just a few clicks, this is really an easy interface to do that. All right. If there are no questions, I'm going to end today's lecture at this point, so you guys can start to do your homework assignment. And I'm suspecting some people might have turned it in already. I'm just going to refresh and find out. No, not quite. I know someone's close. Right, so I'm going to stop the recorder because that's the end of the lecture regarding sprites.